next part, I'm going to run through a batch job, which basically enables the creation of these workloads that the data scientist would like to track. This is done by using runs. And these are runs you would typically run on larger data sets, and you would like to keep track of what was used for the run, as well as the results that it produced, for example, models and so on. So in which there are two types of runs that are possible: a training run and a pre-processing run. A training run generates a model, and a pre-processing run generates a data set. So I'm going to give it a name. Call it MNIST1. And just like the IDE, you can choose the image that you would like the run to use. And in this case, you'd specify the code that should be mounted into this image to actually run your program. So in this case, the program is this. The startup command that it's going to use is available in this subdirectory in your repo. So I'm going to specify that, train.py. As well as this program, this specific program needs a data set to run, and the program expects the data to be available at that path. So this has to match with where your program is written to expect the data to be. So that's MNIST. All the mount paths are also available in configuration files in the pod. So the program could also be written to look at that configuration file to see where the data sets are available and use those. So that's an input. And similarly, this program is going to create a model and write the model files. We write the model files to this directory. Run to completion. So once a run is completed, DKube collects all the files that are written to this directory, versions them into this model repo, and archives them. So once pod completes, DKube does the job of versioning the data that was generated. And so that's the input and the output. And the configuration screen allows the user to provide any configuration as a file that the program expects, or in case of hyperparameter tuning, can upload a tuning file. In case of GPU workloads, you would configure the number of GPUs to use, as well as configure distribution parameters. So in this case, we're not going to configure any of these. So we're just going to go here, check the code is there, the startup command, and the repos that are used, the input and the output, and then submit. So once we submit that, similar to the IDE, it takes a few minutes for the pod to spin up and actually run your training program. Training runs are enable the user to define the workloads, as well as once they're complete, they track the execution of these runs that a user could come back at a later point in time to look at what was used for the training run. The main page provides a summary of the resource usage for that run, as well as the inputs that were used, for example, such as the image that was used to run, and the version of DKube and so on, as well as the metrics that were generated during that run. In this case, it has some simple metrics that are logged that can be graphed here, as well as represented in tabular form. The lineage screen shows what was used for this run, such as the code repo, the data set, including the version, the code with the commit ID, as well as the model that was generated. This model repo with the version says that this was the output of this run. And the logs show that the logs that were generated. So this enables the user to come back to this run at any point in time. And a few other things, that's the tracking and the governance part. And what it also allows is reproducibility. So you could clone a run that was run earlier. You could rerun it to make sure that the model files that are generated match what was generated earlier in terms of metrics, accuracy, and so on. And this tracks, for example, the commit ID. Any of these parameters can now be also changed to schedule a different run. If you want to run it with the current version of the code and not with this specific commit ID, you can remove the commit ID. If you would like to run it on a different data set, you would need to edit this and configure the different data set and so on. So that's how you would clone a run. That gives a easy way of creating a run to you could clone the runs that were done earlier.